After our first panel discussion about the circular future of e-mobility, we are today diving deeper into the potential of giving EV batteries a second life by repurposing them in energy storage systems. For this, we have gathered market and research leaders to discuss the present, prospects, and challenges of the second life market. In the first place, we have the pleasure to have here today Dr. Philip Bundelist. Philip studied material science at the Aachen University and carried out research on the field of batteries in California in 2014. He was investigating electrolyte materials for next-generation battery technologies. Nowadays, he's a senior manager at Accenture Industry X and the head of battery consulting. He and his team have the ambition to strengthen the Europe battery value chain by supporting projects for battery cell gigafactories, energy storage solutions, battery data management, and digitalization and security strategies. Thank you, Philip, for being today here. Our next panelist is Radu Akihai. Radu is the co-founder and chief operating officer at Evion. He has spent more than 15 years in global hazmat operation, and his last company raised 130 million euros for tech development and international expansion. Evion is an Oslo-based company taking a data-driven approach to enabling the reuse of batteries revolution. Thank you, Radu, for being here today. Our next panelist is Dr. Nam Chun. Nam has a background in electrical and computer engineering with a focus on battery storage systems. In 2019, he founded Stable Energy, and Stable Energy, with its modular multi-level inverter, aims to be a game changer in the ESS market and make the repurposing process and deployment of second life storage systems more affordable. Thank you, Nam, for being here today. And our last panelist is Dr. Weihan Li. Weihan is the research group leader at the Institute for Power Electronics and Electrical Drivers at the Aachen University. The research interests of Weihan groups include battery digital twin with physics-based modeling and machine learning, battery analytics and monitoring, aging estimation and lifetime prediction. And in addition, the group is also working on battery fault detection, safety monitoring, fast charging, and operation strategy optimization. Thank you, Weihan, for being here today. Our discussion today is in the format of one slide, one fact, which means that every speaker will share his key message regarding Second Life with one slide. After all slides are presented, we will enter in a broader discussion and debate. Also, the audience on YouTube is welcome to engage with questions, so please just drop your question and we'll pick them up later on. So please, let's start with the slides, and Philip, it's your turn.
Thank you, Cesar, for the introduction. I will give a bit more of the market perspective on the second life of EV batteries, basically looking at the overarching industry that is connected to automotive, to remanufacturers, but also chemistry companies and recyclers and the cell makers. This is just based on some of the observations we currently see in the market. The main statement that I would like to make today is that we have a lot of uncertainties to deal with in the future. And the market is, as you know, at the early stage, yet it's lifting off. And we just need to live with these uncertainties for at least some couple of years. If you look at this left part of the slide, you find some exemplary life curve of electric vehicle battery. Say we put it on the road in 2020, then you will have to deal with the typical times for this vehicle lifetime. Basically an 8-year warranty period or 150,000 kilometers, whichever comes first. But the vehicles will stay on the road and there will be just a little end-of-line batteries returning, maybe 2% of that volume coming back for the market. The majority of the vehicles will then come in a lifespan that is between 9 and 15 years. Here it's currently depicted with roughly 15 years as the maximum probability of the vehicle returning. And we get access to the batteries again. That means that this is the relevant time span that we should look at when we're also modeling market demands in the future. So the vehicle, let's say, lives 15 years. What about the battery? It will probably outlive the vehicle. At least that's indications we have seen based on current vehicle applications and battery developments. And it's not unlikely that a good lithium-ion battery will last 10 to 20 years currently. And with further advances in this technology, it could even be 25 years plus if the calendaric aging is not too bad. So that means that we produce assets right now, we put them in vehicles that will outlive the vehicle. And that, of course, justifies a second use because we have this product, we can keep using it. But what I would like to highlight is we need to consider the time spent also for the battery development, because the typical battery cell development cycle takes 2 to 3 or 4 years. The roadmaps of most cell manufacturers last 5 years, and the battery as an asset lives fairly long. That means we have to look at end-of-life returns rather at the end of that decade. Plus, it's a process we need to consider comparing to the recycling. It's not competing, but alternative process. So the biggest uncertainties will therefore be the lack of the returns that could happen, be it through export of vehicles or people just staying on hold of their cars, not returning it to the market. We need to live with more technical advances, which makes it harder for second life batteries to compete with the new technology. Just think of all technical KPIs, but also more importantly, the cost. We need to live with an information asymmetry if you want to remanufacture the batteries, which gives you only limited access to the data you need to deal with. And usually there will be some big OEM dependencies in the future because they are just the big players in this primary loop in the industry we need to deal with. And lastly, I put 3, let's say, game changers that could change the rules of the market towards the end of the decade. One is a commonly discussed topic, the battery passport, which will facilitate, at least to a certain extent, the battery data management. A second point is really product-driven, with low-cost batteries becoming unattractive for recyclers or having lifetimes of 20 years plus. This will affect the volumes for remanufacturing, repurposing, recycling. And lastly, new business models like battery as a service will also change the OEM strategies because they can stay in control of the battery pack, not giving it to third parties who would remanufacture it.
Great, Philip. Really interesting. You have made a great overview of what is the situation and the prospect of the second life market. And just to pin down or just to set a kind of time window, when do you think that we can expect to have a steady second life battery supply?
I think the steady supply will come now and in the next years because we will have this constant, let's say, background of pre-warranty phase returns of vehicles. Mm-hmm. That should give us some packs to learn it, get familiar with the module pack assemblies and deal with this technically. But mm-hmm. The big volumes, just like for the recycling, will come towards the end of the decade. And currently it's indicated that also this is rather pessimistic forecast because we are also building recycling overcapacities at the moment, simply because the vehicles live longer than anticipated.
Yeah, I do agree. Yeah, about batteries getting to second life or to recyclers before the end of the first life, I would say that it's around 2-5%. This is something that probably you have the same numbers, right? Around 2-5% this amount of batteries that they can get out of the cars before the end of the life, right?
Yeah, before the end of the life, I would agree with this. And then at the end of the life, we need to decide export, remanufacture, mm-hmm. or just recycle to meet the EU targets in the future.
Exactly. You have classified under game changers the battery passport. And if we consider the battery passport as a part of the regulatory legal efforts from the European Commission, what is your opinion of how things are going regarding this proposal of the European Commission? Do you think that it's going to help to boost the second life market, or is going to create burdens to adopt second life modules in ESS systems?
The directives and the passport is definitely making impact. Mm-hmm. But the question is, who's the main target group of it? I think they're looking mainly at cell manufacturers, automotive OEMs, and recyclers, because we have a focus on recycling targets and recycled content. Second life is not the focus topic of the directives, but it could be that we may need more incentives for this market to grow. I mean, there are considerations for repurposing of batteries, but this is currently not favoring small and medium-sized companies in contrast mm-hmm. to the big automotive OEMs.
Right. Maybe this is a topic that we can follow up during the open discussion because I think it's really interesting. Thank you, Philip. Now we're going to continue with Radu von Evion. Please.
Yeah, thank you for the introduction, and thank you, Philip, for a very, very good overview of the challenges that we're facing as an industry. My perspective is going to be complementary to that. So first of all, the Second Life industry is not going to be a one winner takes all. It is going to be primarily a collaborative effort where we believe that Second Life is really a win-win for everybody involved, whether they are technology developers or repurposers or buyers. And in Evion, what we've done is taken an industrialized approach to building planet-friendly, smart and scalable CNI battery systems. And we're saying that not only to emphasize that this is a worthwhile pursuit for everyone, but to also highlight to the market participants, especially the buyers, that there are some absolutely fantastic reasons for investing in battery systems based on Second Life battery modules or cells. One of those reasons is, of course, the fact that you buy products that have automotive quality. And in real terms, that means that they have a 10x lower cell failure rate. And also the modules are built for mobility, meaning that as you want to repurpose them, it will be not a large challenge to be able to pass various types of certifications, since these modules have been built for the tightest of applications, the more restrictive of applications. The second reason is, of course, that these solutions are very planet friendly. So for a medium-sized commercial and industrial application where we take the average manufacturing footprint, we can deliver a solution with a total lower CO2 equivalent of up to 95%, meaning that we deliver systems with a 5% of the footprint of alternative new battery system-based solutions. The third reason is that we are leading in energy density, in most cases with 2 times higher energy density than leading competitors. And in Evion's case, that applies for both new and Second Life batteries. The third reason is that we deliver on very short lead times. So as you go into the market as a buyer, you see that there are large challenges and long lead times. Whereas if you come to Evion, you'll be able to get possession of your system in 12 weeks for smaller systems than 1 megawatt hours, and 24 weeks for larger orders. The fifth reason is, of course, that it makes no longer sense to have just hardware. You need to be able to learn and use those learnings to optimize both the lifetime and the total cost of ownership. That can be significantly expanded in the case of the lifetime or reduced in the case of the total cost of ownership. And then the last reason is that you really want a scalable design. So our systems go from 66 kilowatt hours to 1 megawatt hours, and we're working on solutions to expand this even further. And I believe that is my time, so I'm happy to give my time back to Cesar.
Thank you, Radu. It's really interesting the breakdown that you have done, and we can follow up later on with questions regarding lead times and collective effort and win-win situation in this Second Life market. But I would like to ask you something, because you are really close to the end user. What is the use case that is the most valuable for Second Life? We have home storage, grid balancing, voltage control. We have plenty of different use cases where Second Life and modules can be used. But from your perspective and experience in the market, which one is the most valuable?
I think this is a very tricky question. And the answer is, of course, like everything, it depends. It depends because used batteries, in many cases, have a reduced round-trip efficiency. And that impacts the total cost of ownership in some of these applications. It depends because in some cases, you have to overcome, let's say, reticence on the buyer side and uncertainty. But the way we've looked at it is that the battery systems we're developing, which are DC battery systems, can be used in a variety of applications. And the one thing that we have decided to do inside Evion is go with passive cooling, which of course limits the C rates of the batteries, but also increases the safety of the batteries significantly. Okay. So my answer in short is that any of those applications are good, but of course it needs a lot of analysis to understand whether the batteries are fit for your application or not.
Okay, great. Okay. Thank you for your answer. Okay, now we're going to continue with Nam from Stable, and he's going to tell us and let us understand better how Stable is tackling the technical challenges with your inverter technology.
Thank you, Cesar. So I'd like to speak my mind about knee points. The background is that batteries age because of electrochemical side reaction. That means the usable battery capacity is decreasing. And if we want to put it short, the older a battery gets, the less energy it can store in the end. And now what are knee points? Knee points are basically the events that you see on the slide here, red, yellow, and green, where the steady and slow battery degradation suddenly accelerates. That means that a battery that is usually expected to live on for years suddenly has only a life expectancy of a few weeks and is basically reaching its real end of life. Now, the problem here is that we, and by we I mean the whole battery community, industry, and academia, we do not fully understand the factors and causes for these knee points. Why is that? It's because this topic is very complex. It takes a lot of time to actually make batteries degrade until it reaches a knee point, and there used to be very little interest. Now, if we're honest with ourselves, then the second life industry is still at its infancy and just about to enter its adolescence with more and more commercial storage systems in the field. What we do know, however, are the main factors of what's happening inside the battery. For example, lithium plating, electrode saturation, or impedance growth are the main drivers for these for this aging and also the knee points. And these are rather straightforward to detect and model in most cases. But the issue is that there are also a lot of other factors, including, for example, electrolyte or additive depletion, or loss of lithium inventory or active material. And these factors are again influenced by even more subtle effects like the porosity decrease of the electrode or mechanical deformation in general. And the problem with these factors later on, these are very, very hard to be detected and cannot be detected live at all. They usually require more in-depth analysis, such as a post-mortem analysis, where you have to open the battery cells. The consequence is basically that batteries in the second life, we expect them to reach the knee points at different times. And with this, we say that the proper prediction of these knee points is critical for the industry. And there are quite some players tackling the problem, which some are also represented here. What we don't see a lot in the market yet are ways to mitigate the event of a knee point. And this is something that we at Sail are actually working on. Basically, we're doing smart control of battery modules so we can isolate these knee point stricken batteries.
Okay, great. Thank you for interesting point of view in knee points in battery degradation. I think it's interesting and hot topic, and it's great that you are working on it and trying to mitigate these effects in storage systems. So beyond the knee points and degradation of batteries, what other challenges do you think that there are out there for second life storage systems?
I've talked about a very, I would say, chemical and cell-dependent problem. I also see issues arising in the future with the increasing integration of the batteries in the chassis, for example. We have the cell-to-pack technology, now the cell-to-chassis technology. We need to make sure that the removal of the batteries from the cars is feasible from an economical point of view and also technical. I think this is the next big and more obvious challenge that we're facing.
Yeah, I do agree. So, and just for closing your presentation from Stable, tell us in a couple of seconds how your inverter is helping to integrate modules that they have different state of health or different condition in one ESS system based on second life batteries.
So we have a new inverter topology that actually addresses each battery module individually. And that means that we can handle battery modules that have different capacities, different inner resistances, and also we're able to isolate single battery modules that actually fail and still keep the reliable operation in these cases.
Okay, brilliant. Very interesting approach. Thank you. And so far, we have been listening insights and views from the industry, and I think it's always really interesting to hear also the views from the academia. And for that, we have Beckham, so the floor is all yours.
Yeah, thanks for the kind introduction, Cesar. And also thanks for them for introducing the knee points. So we know that during the use of the lithium batteries, no matter in the first life or the second life, a lot of the stress factors, such as the temperature, depth of discharge, and current load will strongly influence the aging speed of the batteries. Although the prediction of the future degradation is very challenging, an accurate prediction of it is extremely important for second life applications to help us understand how long is the battery lifetime, how much is the residual value of the battery pack after several years of use, and how to use these aged batteries in second life safely and cost effectively. As we can see here from the battery aging data set from our lab, the variability in the degradation trends of the batteries in early life is very small and only starts to increase greatly from the midlife of the cells onwards, which is a big challenge for battery aging prediction in early life. At the Center for Aging and Lifetime Prediction of Electrochemical and Power Electronics Systems at RWTH Aachen University, we have developed several models with machine learning for battery degradation prediction, and the main framework contains 3 steps. The aging experiments are performed first on several cells of a similar type to the intended use case, obtaining a dataset for supervised learning. This dataset is then sent to the training server, which has computing power for model training and distribution. The server's next task after training is sending the best performing model to embedded devices. The connection is bidirectional, since devices also transmit their prediction data and other metrics from the field to the server, which can be used for future model updates. Since each cell's data is sent to the server tagged with a particular ID, a unique cell passport can be created, which is useful to track performance over the entire lifetime, and also makes providing updates over the air to the models present in the BMS a trivial task. The cloud connectivity is a key factor that enables the model to be continuously updatable, and the model output can be sent to the various systems supporting operation strategy optimization, predictive maintenance, and full life cost analysis as needed. On the right-hand side, we are showing some example of the degradation prediction results at different life periods of the batteries. With this cloud-based battery digital twin, we are able to predict not only the end-of-life points, the degradation knee points, but also the whole degradation trajectory of every single cell. We would like to increase the safety and reliability of the batteries in both first and second life applications with our digital solutions. Thanks. Cesar, I cannot hear you.
I think now, yeah. Great.
Yeah.
I was saying that it was very interesting. It's a really interesting approach, and it's really nice to see how you are closing the loop of the life of the battery using data completely from the first life to second life. And I wanted to ask you, what are the main challenges that you see gathering data, performance data of the batteries in the cloud? Because your approach is basically to kind of simulate a BMS, so to say, in the cloud, and be able to improve the performance of the battery in either cases when they are installed in the EVs or they are in the stationary storage systems, right? So what are the main challenges that you see right now collecting data in the cloud?
I think if we would like to use a model to predict the lifetime of the batteries in the field, we need to have some data set that is useful for us as the basis, right? So we usually do this in the lab by testing the cells with accelerated aging test. But such tests is not the same in the field, right? So we do not have so much stress for the battery cells. So I see the challenge here is how to design the accelerated aging test in the lab in a way so that we can generate the data set that can be used efficiently for at least for this basic model. And so that we can use this model and getting more data from the field and update it so that it can always predicting the battery lifetime accurately for every time point in the field.
Okay, I see. Good. Great. And if we speak about how we can rate batteries and sorting and classifying batteries for moving those batteries and modules from first life to second life, how do you see the outlook for new solutions, especially using database methods like machine learning on combining physical methods with data-driven methods?
Yeah. I think this topic is very important right now because we see a lot of batteries are being used for the second life. But if we do not have the data from the first life, it is very difficult to guarantee that the battery will be always safe for the whole life of the second application. So I think the solution for this are mainly two directions. So the first direction is we need to really develop some method that we can evaluate the battery safety and aging status very quickly. So the standard way we do this is do some, capacity test and resistance measurement, but that is not enough and always take a very long time, right? We can combine machine learning and other physics-based models in this process to accelerate it and give us a more comprehensive understanding of the battery status. So the second solution is we need to collect the data for the battery pack with some battery passport in the cloud for the whole lifetime from the beginning in the application to the end, so that we can follow the status of the battery so that we know directly, even without a very complex testing before the second life, exactly the status of the batteries.
Yeah, I do agree, and this is going to be an interesting topic if we can follow it up during the open discussion, because it has a direct impact in the economics of the second life market. So you have dropped really interesting insights regarding the second life market's economics and technology and repurposing. But as I was saying, I think the economics of second life, I think, is really important. And as you were saying, Weihan, physical testing takes time, and it has a direct impact in the cost of repurposing batteries and modules for second life. But I think, Radu, here you can maybe help us to understand better what are the steps that you are doing in Evion and how we can reduce this cost and get it more efficiently. Radu?
I'm sorry, I think I dropped out for 1 second. And I didn't hear the question, Cesar. And now you're...
How we can rate and sorting first life modules that they were in first life, and we want to move them in second life, how we can rate them, sort them, classify them for repurpose them in second life. Most probably you have a good experience doing this process, and I'm interested in knowing how this impacts in the economics of second life.
I think that's a very good question, but I think it makes some assumptions, which are one, that we need to have a good track of, or we don't need to have a good track of their first life. So one of the major challenges that I see to the overall safety of the industry is the fact that some repurposers take, let's say, crashed batteries, taken damaged batteries or flooded batteries. And I think that is a big risk, and it's something that is very difficult to do and to track accurately. That's because you have a third party here that is involved and that's more interested in, let's say, the monetization of those batteries than actually spending money, and that's the insurance companies, right? So you have a crash car, it becomes the property of the insurance company, and the insurance company has a vested interest to try to monetize on that battery. So our overall approach is, first of all, we only source batteries with a certified provenance. The second is that we do some quick testing, EIS, and we back that with the machine learning. We're building actually one of the largest second life battery test labs in Northern Europe to do precisely that. But until that point, we don't take any risks. The batteries that we source are pre-certified by the OEMs, and they go through a variety of tests to ensure the safety and the provenance of them. In terms of testing, I fully align with Weihan, and I defer to his knowledge. I think it is extremely important for us to develop quick solutions to be able to test them, but this is only going to be complementary to a first life assessment that will come from the battery passport. I'm looking forward to that. The third thing, which is a concern related to that, is first, the implementation of a battery passport is going to take money. So it's going to be another battery to entry to any company trying to participate in the second life market. And that needs to be addressed through very easy implementations of the battery passport. And that means that, at least in my mind, the second life industry needs to have a stronger voice in front of regulators and in the industry overall, in the battery industry overall, so we can voice our concerns and move our agenda forward.
I think we are putting already the ingredients for a great discussion, because we're speaking of if the systems are safe or not safe. The voice of the second life stakeholders is really important to be recognized in the process of the second life market and battery regulations. But let's try to get back 1 second to the economics of the second life market. Philips, you were presenting an overview of how the second life market looks like. Do you have 3 components, or can you describe the 3 main components that drive the cost of the second life market? So the repurposing of batteries into ACS systems.
Yeah, that's a very complex question, and maybe start with the historical perspective, because we're coming from a decade where the battery costs have decreased almost by a factor of 10. And this is something we will probably not see again, because we're reaching a level of material cost dominating the battery cell production cost with 70, maybe even 80% in the future. So that means by 2030, a new battery, we expect them to cost around $60, $70 per kilowatt hour. Not 1,000 like in 2010, not about 100 like they are now. So that means we have a bit more room to operate in the future, because the cost digression is not as rapid as in the previous decade. That's good news. Another factor we need to put in is basically the cost for repurposing. If we want to reassemble modules and get the cells out, we need the scale effects to run it efficiently, like very cost efficiently. And then we're talking about a system integrator, like system disintegrator factories of the sizes of maybe a gigawatt hour onwards, that you can have, let's say, 50 packs minimum per day, maybe automatically dismantled. So you have the scale effects and a lot of automation in there. And another effect is the cost acceptance from the market. That's the third part of the puzzle. Because if you go for applications like the home storage market, there were some polls in the early days. People are willing to pay, let's say, 50% for a repurposed battery compared to a new one, because of the risk or the stigma that these batteries may have, which could be debunked, though, with modern technology. But there are many applications, products, and niches where you will find a good price for your battery, where customers will be willing to pay the dollars per kilowatt hour or per cycle. And they don't care if it's a fresh battery or a repurposed one, as long as you give warranties and safety certifications.
Yeah, I see your points, and I may ask if you will add the logistics involved in the collections of batteries and modules. Do you think that it's a cost, this important cost, or we can neglect this? Because at some point we're going to reach a critical mass, and geographical distribution of batteries is not going to have an impact.
Definitely, it's coming, and we're setting this up. And this is where we're working with recyclers who are setting up their logistics and partner networks. So this will be providing the infrastructure for a vehicle battery collection in the future. And if you have a network of workshops and recyclers and also repurposers, I think the logistic cost will drop in the future, and probably the regulations for battery transport will also hopefully change to a more favorable position.
More clear, yeah, sure. Okay, you were saying that it's gonna be a pressure from the cost coming from the reduced cost of new cells, and it will combine so to say that the new technologies and new chemistries are going to be cheaper than the old one, but in addition that, for example, LFP batteries are going to be a game changer. I think you drop already a hint on your slide, Philippe, when you were saying that they're going to be new technology that are going to be cheaper with a longer lifespan, and this is going to be an important event in the market with LFP batteries are going to be more present, right? Radu, I don't know how you see it.
I think that, so thank you for the question. I think it's a very interesting long-term perspective that we have to take at our own industry. And I believe that Philip highlighted something very important in his slide, which is that, of course, chemistry and technology are going to be having tremendous impacts on the future of our industry. The fact that the, let's say, recycled value of the batteries is going to change as the transition moves on to LFP is going to impact negatively the appetite of recyclers. And that means that repurposing is going to have an increasingly important role to play, as long as it can deliver on quality. And I think second, there's a lot to be learned in this industry, because it's the first time we have a real opportunity for a truly circular play that is cash positive throughout. I think here we're looking at multiple sources of batteries that we really have to consider. Although their proportions are, let's say, going to be tilted towards used second life, we have to consider the fact that, first of all, not all batteries come from second life of batteries. We're talking about overstock, we're talking about warranty stock, we're talking about production issues, let's say packs that get damaged during manufacturing and end up on the market. And we have to take all those packs and put them in, and they have they represent a fantastic opportunity for second life battery use, and they don't get impacted, and their economic case is absolutely fantastic for us, but it's really, for the recyclers, the actual value and the actual quality of the battery system makes absolutely no difference. As a kind of quick summary, I believe that the change in the chemistry is only going to be favorable, because as also Philip noted, the material cost has become the dominant component of system manufacturing. So in reality, it's going to be less and less competitive for recyclers to take a long play.
Okay, let's do Beihan. Nam, do you share the opinion from Radu and Philip, or?
Yeah, I also think that we're currently talking a lot about the costs that are associated to Second Life. And if we say that the chemistry will change for cheaper batteries, ones with more longer lifetime or higher energy density, then we should be aware that all these batteries will probably go into the automotive field. And that the question is not anymore a question of pricing, but a question of availability. That's what I believe. So even if we had better batteries that would be more suitable, I'm pretty sure it will be harder for the stationary industry to get their hands on. And that means if we are able to deliver storage systems with second life batteries, then this is a huge competitive advantage already.
I do agree, and Philip already mentioned this in the third game changer, right? Battery as a service and the possibility that the OEMs stays in control of the batteries. Something to add there, Philip, because I think it's a very interesting point what Nam said.
On the battery swapping in particular, that's something we need to keep an eye on, because it's especially popular in countries where you don't have access to charging infrastructure that easily. So there is more competition among the automotive players who want to stay very innovative, and giving that option to bring also new technologies faster in the market with the exchangeable battery pack kind of allows them to monitor the technology on the road, gain access to the data, don't bother that the battery is not returning. And then with all of this playing together and staying in control of the battery as OEM, they can decide what's best. If you have like a new solid state cell that you're experimenting with on Chinese roads, it's 1,000-kilometer range, but very poor cycle life. People wouldn't know, because you can just easily scrap it and then repurpose or just replace by a different set. So there will be advantages from that system. The question is, will it also be feasible for Europe? Because we're currently investing a lot into the charging points and setup of that infrastructure.
Yeah, that's right. Okay, we will see in the future how this is end up. And one point that we mentioned a couple of times already, and I would like to address now, is how safe. So how we can, if we can consider Second Life storage systems safe or not. My opinion are safe, but I would like to understand how is your what is your opinion, and for instance, Radu, in the case of Avon, what are your technical approach to increase the safety of the SLS based on Second Life systems?
Thank you, and thank you, Cesar. And I think that's a crucial question. So it's been mentioned before that the customers have this perception of inferior quality because we're talking about Second Life. But in terms of safety, I think there are four main things that we can do to increase both that perception and the reality of the higher safety. First is communicate really well around the fact that, at least in the case of automotive batteries, these go through levels of quality assurance that are not seen for battery energy storage system cells going into stationary application cells. So you get a 10x lower failure rate, and that's translated into the quality of the Second Life battery based systems. The second thing is that you do have the same level of quality in the monitoring or the hardware monitoring as you have in any other application. So the hardware that's controlling the state of safety of the batteries is exactly the same, whether you're talking about brand new battery systems or Second Life battery systems. And it's like the Second Life batteries, they function in a completely different manner. The third is that you can apply machine learning to do digital models or digital twins that anticipate failures. And you can use that together with very high quality hardware in order to just stop the operation of any cell or any module that is exhibiting any sign or any, let's say, indication of underperformance or instability. And I think the fourth thing is that we need to ensure I kind of mentioned it before, but we need to ensure that in order to stay competitive, we don't cut corners when it comes to the quality of the hardware. And also we need, and that means that we in general use top shelf components for everything that's related to safety, meaning top level battery management systems. We're using top level components, electrical, active and passive circuitry. So overall, there's really no difference between our systems and brand new battery systems, except that ours are better. They are based on automotive batteries. They have high density, etc., etc. And then I think the last thing that we need to keep in mind is what are the failure reasons behind any kind of battery systems. And the primary causes for concern are malfunction of the battery management system or a malfunction of the cooling system. And we've avoided the second one completely by taking a passive approach to cooling. Maybe somebody else can add to that as well. Okay,
great. Radu, for your point of view and your experience. Weihan, how would you see it? How with your approach that you presented before, how you can prevent that Second Life batteries in ACS systems can have any kind of technical problem or anomalies? Because since you have a closed loop, getting data back from the ESS systems, I'm pretty sure that you're working also in the prediction of failures and in events that can lead to problems, right?
Yeah, I think I totally agree that safety is catching more and more attention from different OEMs and also from the research institutes, and we are also working on how to defect the aging in two ways. The first is the aging related safety problems, and the second thing is the battery faults that happens suddenly that it's not able to predict based on the previous data. But for doing this, I think it is very important to understand, as Rado has mentioned, why these safety issues happens, right? So what are the physics behind these safety mechanisms? So that's why we're also working on building up the physics-based models for different safety-related faults, and also the long-term aging of the batteries. And I think the final solution for aging and safety detection, prediction, and monitoring should be combining the strengths from physics-based models and our understanding from physics, together with the data we collected from the field and with the machine learning to increase the generalization ability of such models.
Really interesting. This is something that maybe we can discuss in just one monotopic panel, because this is a really challenging project if we want to combine all these methods to detect, prevent, and forecast problems with the batteries. And just for closing this part of the debate, Nam, what is your point on what you take on safety on ESS systems, and especially using your technology?
Yeah, so I agree with Radu and Wehan that we need to keep the quality level of the electronics and all the algorithms at a very high level. And I think since we're all in the Second Life industry, we are very well aware that we're being closely observed regarding the safety because of these customer concerns. So I would assume that most players in the Second Life field take these issues very seriously. So I would expect the failure rates for battery management systems or wrong state estimations would be rather low, and we don't need to expect failures from these. And since we are working with batteries that have been tested, that have gained experience in the automotive field, I would also say that the safety here is higher, because we do not have the cases where a new cell design is being deployed for the first time in a larger scale, but these new battery cells that, I don't know, have a new design and have a higher risk of exhibiting any risk factors are tested in the automotive field already. So what we get are the tested and proven battery cell designs, and that actually is a argument for the safety in the Second Life.
Okay, I see. Okay. We have around 10 minutes to go, and I've been checking the comments and questions from the public. I think we have a couple of questions that maybe would be interesting to answer. So if you don't mind, we'll pick them up, and feel free to answer whoever thinks that can do it. So let's start with this question. I understand that batteries from different manufacturers might be using different chemistries. Do you see it technically feasible to have different chemistries integrated in the same storage solution?
Definitely. If I can answer that question, I think this will be coming, and hybrid systems is one of the trending topics. Could be hybrids of lithium-ion and sodium-ion batteries. Get a bit of the power capability of sodium-ion and the range of lithium. So that could be a mixed system, but it would probably or could come from the same cell manufacturer. I think automotive players will likely stick to one vehicle, one supplier for it. They have multi-sourcing strategies, but they will not mix a CATL sodium battery with an LG lithium-ion or polymer battery, I think. But yeah, it's coming. And for repurposing, that could be a very interesting approach to really tune the properties of the use case you're addressing.
Yeah. May I have another comment on this? So
Sure.
I really think that the hybrid battery systems is very important and potential solution for stationary battery systems. Probably not for the automotive because it will be expensive and there will be more power electronics needed. But for stationary battery systems, for example, we have already operated a 5 megawatt system, stationary system, battery system in Aachen for so many years by combining 5 different battery technologies. And by doing this, we are able to design the energy management systems ourselves so that we can optimize the aging of every different battery chemistry. And this will save a lot of money. And this will be some solution for the OEMs, especially for the stationary battery systems, to generate more benefits by combining different chemistries and even the different second life batteries with different aging stages together.
Please, Radu.
If I may also interject with a bit of a contrarian view here, which is related to the fact that complexity drives cost. And although I agree that what you're saying is perfectly feasible and doable, we are in reality competing with first life batteries, where there is a consistency in part supply, is a consistency in the supply chain, in the procurement, and adding complexity generally doubles the cost of logistics and everything else. So I believe that there would be a lot of value in building hybrid systems, but I do not believe they will be cost competitive. That said, we have to take into account what we've all been talking about before, but especially now, which is availability. Some customers for which the availability is critical are going to pay extra to be able to get batteries now versus get them into whatever the lead time is now, 9, 12, 18 months. So again, my perspective is it depends a lot on the application and takes a lot of analysis to say whether something is going to be doable or not. And just a last point, basing your production on 5 different types of cells is going to be extremely difficult because you need to source those 5 different types of cells consistently for your product.
Yeah.
Thank you, Radu.
I agree with Radu that this topic is rather controversial. The first time I heard about hybrid storage systems was 2013. At that time, it was already a good idea. Until now, I haven't seen any commercialization that justified the cost so far. From a technical point of view, I agree with Vaihan and Philip that it does have some benefits to combine the different properties of the cell chemistries. But as Radu said, we're barely handling one cell chemistry properly. So in the next 5 to 7 years, I would probably not see a lot of hybrid systems. After that, as soon as we have matured as an industry, maybe it comes back into play. But right now, there are more complexities that most industry players would probably rather avoid than introduce.
Okay, interesting. Then let's move to the next question. The next question is around battery passports. We haven't touched this topic. We can do it really quickly. I have seen that you have. We all agree that battery passport is digital battery passport is interesting and required in the battery market. I think there's no discussion there. I think the discussion probably is around which kind of data is going to be in the battery passport and who has access to this data and when has access. Right. So I don't know if you can give enough in 30 seconds what is your opinion about the passport and what your expectations. So we can start with Vaihan.
Yes, battery passport is always, especially this 2 or 3 years, a very important topic in our institute. And we are mainly working on, so beyond the standard indicators in BMS, such like the standard SOH, CSOHR, which kind of other information need to be involved in the battery passport if we are able to log the data in the cloud, right? So our understanding or state of the art in our institute is we would like to not only include such resistance and capacity values of the battery, but also some deeper understanding of the aging, such like the aging mode of the batteries. How much % of the aging is due to loss of lithium inventory, is due to loss of active material. This can be done by analyzing the charging data of the batteries. So this is one of the solutions we have provided. And also some other indicators like, for example, related to the safety, right? So whether there are some other indicators, we can have them in the battery passport to tell us the state of safety. So state of safety is quite new, and we are still working on it. And to optimize the indicators we are able to extract from the field data. But we really think that state of safety is another important indicator we need to have in the battery passport.
Okay, I see. Radu, what's your take on the status of the battery passport and what you would like to see in the battery passport definition and specification?
So I believe that is going to be an important part of the identity of the battery, and is going to help clarify some of the important questions, like how much should I pay for this battery? How long is the expected lifetime for this battery in a specific application I'm planning to deploy it in? But my general perspective is that as anywhere, any system is as good as its components, its data sources, and its users. So I think that the battery industry faces a huge challenge in implementing the battery passport. We have to think about the fact that standardization has always been a challenge. We all like to do things differently. We all like to diverge. We like kind of arguing for our own solution. So I am really looking forward to it. I believe standardization is the way forward. And even an imperfect system is better than no system. So Weihan with the efforts. And Philip, I hope you drive your customers to adopt a solution ASAP, and we're all going to benefit from it.
Yeah. I wanted to ask you also, Philip, as an expert of the battery supply chain, how you see what is the role it's going to play in the supply chain, and if you see something missing in the current or ongoing definition of the battery passport that could help to improve the communication and the information sharing among the stakeholders of the supply chain.
I think the concept itself, it's a good idea. And since it's coming, people know that it will be there in 2026. But we see too little actions from the automotive industry, from recyclers, and everyone who has to deal with this topic. I don't know if they just want to take that time and they will be ready by 2026, or if they are just ignoring this for now until more policies and decisions have been made. But I mean, there will be these 3 layers to the passport, one for the public. I think this is interesting also for the end customer to learn a bit more about the battery. Probably not too interesting for us as the industry people. The second layer will then be the delicate one for the repurposers, the remanufacturers, recyclers, with just assembly instructions and also some detailed lifetime estimations to really maximize the economic value. That's the important one. And the third is just for the policymakers, also not too relevant for us. And I really hope that they will find a common ground, that OEMs will be willing to share information beyond the absolutely minimum what's required from them, to open up a bit, and that they not say we keep all BMS and lifetime data for us because we find other ways to monetize it.
Yeah, I see. Great, and thank you for the open opinion. And now for closing this point, and then I will throw the question that we had from the public.
Yeah. So yeah, I can only repeat what the others said. I would say the usefulness of this battery passport depends a lot on how much information we get. If it's just about the remaining capacity and the impedance, that is something that we can figure out relatively quickly, and it doesn't cost a lot. But just as Weihan said, knowing the charging protocol, what the temperatures were, how the batteries were used, gives a lot of indication on what the different aging mechanisms were. And I think this is a crucial and critical information for the topic that I have been pitching, the knee points, so we can actually predict the lifetime of the system. So I think, but as Rado said, little information or imperfect information is better than nothing. So it will be an improvement. How much really depends on how willing the OEMs are.
I do agree. Well, time goes by, and unfortunately, we are reaching already 1 hour of discussion. I think that we have topics left aside of discussion, and we can make even a second round maybe in the future. It was great to have you here today, and really interested in your opinions and your insights. Thank you for all the questions and comments in the YouTube comments. We couldn't answer all the questions. We'll try to catch up offline. And well, to everybody who was watching, I was interested for them. We're scheduling these kind of discussions with the market leaders and researchers. So check out our LinkedIn feed to see when we're going to organize more events. And I can only thank you and wish you a great day. Thank you, guys, and see you soon.
Thank you.
Thank you.
Thanks. It was a pleasure.